Hello. In a previous video, we looked at completing the square as a visual model for quadratics that had a leading coefficient that was equal to 1. In this video, I'm going to show you how to use a similar method to complete the square when the value of a is not 1. Okay, so the first one we're going to look at is a quadratic with a leading coefficient of 2. So we've got y equals 2x squared minus 12x plus 25. Currently written in standard form, and we're going to use this visual model in order to rewrite it in vertex form. So this form is called vertex. Okay, so the first step is looking at the squared term. There are two x squared values. So in my model, I'm going to draw two little squares. And probably I'll put about that much space between would do the job. So each of these little squares represents x squared, and there are two of them. Next, I'm going to look at the linear term. In the linear term, I've got negative 12. So that means that I'm going to split that negative 12 between these two x squared terms. That's going to be two groups of negative 6. Negative 6x is then going to be organized into two groups. One group on the right of the little square that I've drawn, so 1, 2, 3, and one group on the bottom, coming out this way. 4, 5, 6. And then the same on the second little square. 1, 2, 3, 4, 5, 6. So currently, what I have drawn here in my model are the first two terms of that quadratic. Next, I'm going to look at what is remaining in this white space in order to complete the squares. In this case, there are two of them. So there's one, and there's the other. I'm using color to make it a little bit easier to see what's happening. I'm also using, you'll notice I changed from blue to red. That was to help me remember that I have some negative terms in my x values, in my linear term. Okay, so what did I add in here to complete this square here? I've added 9 units, and I've added another 9 units here. So out of the 25 that I had available in my constant term, I have allocated 9 and 9. So two groups of 9 is 18. So what's left of that 25 when I subtract away 18 is 7. So now I'm almost ready to write this in completed form. So the dimensions of each of these little squares, which are identical, and they should be, or I haven't done it right, the dimension across the top is x minus 3, and across the bottom, or down the side, is the same. So it's x minus 3's. So what I have in my model here is two squares of dimensions x minus 3. And then what's remaining of my constant term, after I've constructed those two things, was 7. So there's my vertex form of that equation. Okay, that was one. Let's look at another one. This one is leading coefficient of 3. Okay, 3x squared minus minus 18x plus 29. So the initial step is just like I did above. In this case, I have 3 little squares. So I'm going to go 1, skip a few spaces just to make sure I've got enough room. Skip a few more. Okay, that should be good. So each of these little 2x2s that I've drawn are representing one of those x squared terms. So I've got 3 of them. 1, 2, 3. Now I look at my linear term, negative 18. 18 can be divided evenly between each of these 3. That makes 6 each. So similar to above, 6 and 6. So I'm going to split those evenly to the right and below. There we are. So there's all my 18 x's, negative x's that have been distributed. And now I have the constant terms, how to complete each of those 3 little squares. So there's one here. So 9 units are going to go in each. So if I've allocated, from a constant term of 29, I've allocated 3 groups of 9 units. That's 27. So I'm going to take away 27 here from this constant term. That leaves me with 2 left over in that constant. So in my vertex form, the dimensions of these smaller squares, same as above, it's x minus 3 by x minus 3. And there are 3 of those. And I had 2 units remaining. Okay. Let's look at another one. This one's going to be a little bit different. Oh my, look at all those decimals. So one of the things that often will happen when you're looking in a textbook where they're asking you to complete the square is it will go from a values of 1 to a values of some nice whole numbers like 2, 3, 4, and then the next step in that process is you would be introduced to leading coefficients or coefficients that are decimal values. So there's nothing fundamentally more difficult about it. It just looks different and a little bit trickier because of the presence of decimals. So the first piece in this process, what I would do is a little bit of algebra and rewrite these. Instead of decimals, I would write them as values as a fraction. So this is 1/10. Point 4 is 4/10. And 0.6 is 6/10. So in doing that, what I see is that I've actually got some nice whole numbers, 1, 4, and 6, that have been divided by 10. So with one step of multiplying this whole equation, left and right, by 10, I can transform or rewrite this equation in a way that it gives me only leading coefficients or coefficients that are whole numbers. So I'm going to do that. I'm going to multiply by 10 on both sides of the equation, and the result of that will be that I will have 10y on the left, and on the right-hand side it will become x squared plus 4x plus 6. And already now on the right-hand side I have something that will lend itself to modeling more easily. And I'll deal with that 10y later on. Okay, so we're going to do completing the square now using the method that I was showing above. So I've got x squared represented with a little square that is x by x. I've got 4 x's that are going to be distributed to the right and below. So that's going to be 2 and 2, like this. There's my 4 x's. And then to complete that square, I would need to add 4 units. Right there on the bottom right. So what I'm doing is, let's go back to my yellow here, minus 4. So out of that 6 that was the constant term, 4 of them have been used to complete this square shape. Okay, so we've got 10y still on the left. I haven't done anything about that yet. Is equal to the square of, this is x plus 2, a little square with dimensions x plus 2, plus an extra 2 units that did not get placed. So at this point, it almost looks like vertex form. The only thing that remains is to divide that 10 away again. So I basically multiplied it off to the left-hand side in order to get it out of the way so that it wasn't complicating my diagram. And then I'm going to divide it back in order to isolate for y in the final form. So final form of this equation is going to be y equals x plus 2 squared plus 2 all over 10. So in this form, I can pick out the vertex, and my leading coefficient was positive, so that tells me something else about the parabola as well, that it opens up.